Hello students, welcome to week 6 of our remote learning experience in robotics. This video is being uploaded April 28th. That's a Tuesday of this week. This is the first of 2 videos we'll have this week. I'm going to start out by taking a look at our PowerPoint. The first 3 weeks we had several different assignments due to each week. So those are weeks 1, 2, and 3. Some of you that have just logged on are just now getting into those. And a lot of you are finishing them up. Even today, I've been getting a lot of assignments turned in. Weeks 4 and 5, weeks 4, those assignments are all due. Week 5, we had a How Do Fans Work worksheet that was due last Tuesday. And then this week, the fan project is due on Friday of this week. Also, we'll be doing a history of timekeeping worksheet. That'll be assigned today. That'll be due this Friday also. The project that was supposed to be done last week, the fan project, and it's due this Friday. You're supposed to be doing 2 pictures. One would be the prototype, the one that you tried out first, and then the second one is the finished project. So this is an electric fan. This was the prototype that a student put together, and then this is the more refined version that would count as the finished project. And he did an electric fan. On this one, this is a really good example. This would be the prototype. It's rough, and then this is the final fan. Looks like he used a paper plate and a stick of some type. So this is a really good example of how you're supposed to do the prototype and then the finished project. And on this one, I've got one above the other. This would be the prototype made with a pencil and some playing cards, and this would be her final version. It looks like maybe she used 2 pencils to hold on to instead of 1. So you're supposed to be turning in 2 pictures. It doesn't have to be videos, it does have to be pictures. We're going to continue following the weekly schedule. Yesterday I mailed out an update for the class. Today we're going over a lesson topic and the worksheet assignment. Tomorrow we'll have a Zoom meeting. Only a few people have been coming to those. If you have questions about this class, you should come at that time. I can show you videos. We can use the whiteboard and I can share information. If you're having problems understanding how to measure, should be able to explain that to you pretty well one-on-one. We'll have a project assignment this Thursday, just like the projects that we've been doing. And then Friday, we'll have a wrap up for the week. And if you have things you want to work on over the weekend, just a wrap up of how to do those things. Today, the topic for this week is going to be timekeeping, the history of timekeeping. And here again, we're trying to do projects where you don't have to go out and buy something. And we're working with things that you would have available at home. Everybody's got something available home that they can do these projects with. So I've tried to keep them simple. And you'll find out more about the project this week. Today, we're going to go over just about timekeeping, just a very brief history of timekeeping. It says, what is a clock? A clock is something that ticks. It's regular, it has repeated action, it's used to measure time. And the ones that we're looking at here are most likely driven by weights, or the one in the middle and the one on the right, or electric. Could be that you plug them in the wall. They could have batteries. But whether it's a clock, whatever type of clock it is, or whatever device it is that you're keeping track of time with, it's all related to astronomy. The Earth orbiting the sun, like the picture on the left, that's how we know how much a year is. And then the Earth rotating on its axis lets us know how long a day is. So you don't need something fancy to know how long each day is. You can just watch the sun come up and set it at the end of the day. But this is Stonehenge. You've probably seen pictures of this. This was used to keep track of the days, but also based on how high it went in the sky, they could tell when a year had elapsed. And then you've probably seen these also, sundials, that did a fairly accurate job of keeping track of time by the hour. So the earliest ones you'll see on the left, it says 1 day was the accuracy. Over here on the right, the sundial, the accuracy is 1 hour. So as time went on, we became more accurate. Drips and drops. This is a Chinese water clock. It's hard to tell what's going on here, but they put water at the top, and then it would probably turn a wheel or gears, and that would help determine the time in an accuracy of minutes. This is an hourglass. This is something that you can make. You can buy them. A lot of times they have egg timers that'll time 3 minutes, so you'll know how long to boil an egg to make it a boiled egg. And that has an accuracy of about 1 minute. This is one of the first mechanical clocks. It had a pendulum. The longer the pendulum, the longer it took to swing back and forth. So you could make it more accurate by adjusting this weight, how far up and down it was on the pendulum swinging back and forth. And you notice now they were keeping time within seconds. So at the end of the day, they may only lose a few seconds instead of a few minutes. Quartz oscillators. You may remember when we talked about sources of electrical energy, we said there was something called a piezo crystal. It's a type of crystal that if you hit it with a hammer or you squeeze it really hard, it releases electrical energy. Well, just as it will make electricity, if you put electricity into that crystal, it'll vibrate. And quartz is one that vibrates at a pretty um, constant cycle. It's called resonance. And so that's vibrating, happens pretty accurately. And by attaching that to a motor and a series of gears, you can create like a wristwatch or a clock. And it says down here it's accurate to within 10 seconds per year. So it's a whole lot better than the mechanical clocks with the pendulum. Instead of losing a few seconds a day, you're only losing a few seconds per year. State of the art for us today is the atomic clock. It's very, very accurate. You'll notice down here at the bottom, it loses 1 second in 3 million years. And at the current time, they're working on clocks that are accurate, that will be accurate within 1 second every 4 trillion years. And they're using light to do this. So what's the big deal? Why do we need to be so accurate in our measurements? Well, one example is the GPS system that we can use to find out where you are or leads us on maps to different places. It uses satellites. It says down here at the bottom, there's 24 of these satellites orbiting around the planet. And by the way, the GPS system was created and maintained by the United States Air Force for the whole world. So whether your enemies or friends, everybody in the world can use the GPS system, and it's maintained by the United States Air Force. So there's these different cycles and different orbits that these satellites follow. So for example, if you had 3 satellites and you were getting signals from that satellite the same amount of time from those 3, you would know that you're right here where the 3 of them come together. Usually you can tell how far you are, your location, and find out how far you are from those satellites using 3, but more likely they like to use 4. It says satellites broadcast time. You compare the signals from all 4 satellites, and that depending on how long the delay is from each satellite, you can figure out where you're located. It says it gives the position on Earth to within a few meters. So I've been sitting on a couch before with my phone connected to Google Earth, and I can put it on the left side of the couch and I can see my latitude and longitude, and then move it to the other side of the couch. And just in that little distance on the couch, there's a change in the latitude and longitude. So it's pretty accurate if you can do it within a few meters. A few meters is like less than 10 feet or about 10 feet. This week, you're going to find out more about timekeeping. On week 6, it says History of Timekeeping Worksheet. You'll have 15 questions. Some of those will be answered from a video, I think 1 through 12 on the video, and then numbers 13 through 15, you'll find the answers on the History of Timekeeping PDF. You can accomplish this lesson in like an hour or less. We've got some people that have been guessing on the answers on these worksheets, and if you just guess, you're gonna have a failing grade. There's usually 4 answers for each one, so you'll just by guessing, like if you counted every one as letter A, you'd end up with a 25%. So you actually need to be paying attention and reading these and not just coloring in the dots. This week's project, which I won't be announcing until Thursday, but I'll give you an idea about it so you can start researching it. It says here, begin researching and thinking about a device you can build to keep track of time. Project assignments and guidelines will be announced Thursday. So just take care of the worksheet for now. It gives you a couple days, well, 3 days to get that done. Then join me Thursday. I'll be showing you examples, giving you some ideas about how you can create a device that keeps track of time using the materials and equipment you have at home. So until then, continue to stay safe and keep on your Google Classroom for all your classes. Any questions at all, just email me. And I've been getting about 30 messages a day from students about work that they've either completed or questions they have. So until next time, be good. See you.